Hey, on today's on.net show, we're going to be talking about build automation with Nuke, so you can make your build faster, better, and more reliable. And we're going to be talking with Matthias. Check it out. Hey, welcome to another episode of the on.net show. Today, we're going to be talking about build automation with Nuke with Matthias. Hey, Matthias. Thanks for being on the show. How about you do a kind of quick intro, and then we'll get into the topic. Yeah, so do it.
I'm working on Nuke for like 4 years already. In my day job, I'm a developer advocate at JetBrains, and that's my project I want to talk about today.
That sounds perfect. So let's start from like kind of the top. What is Nuke for? What's the domain that it fits in? And then what are some other projects that are maybe similar to it that people might be using today that would give them a clue that they should maybe look at Nuke as an alternative?
Okay, so first we can share my screen. Then I've prepared one slide here. What is build automation in general? So I think this picture, which I took from the Gradle website, shows it quite nicely. Build automation means that we put in our source code at the front of something like a build pipeline. And in the end, we end up with something like a deliverable. And in between, there can be various steps like compiling the solution, restoring packages, of course, all that kind of stuff. Yeah. And speaking of alternatives, so in .NET, there are several. Of course, everyone should know, I hope so, at least MS Build. So that's one that everyone uses. But MS Build is more like, I like to think of it as the more lower build system. But Nuke is more of a build automation system that sits on top. So it doesn't replace MS Build, but it is an orchestrator tool. That's at least part of it. And there's some alternatives, of course. Yeah, there's like Fake, I think, was one project that really pushed build automation in .NET forward into a quite good direction. And closely afterwards followed, I think, Cake, and then also Bullseye and Fubu Core. And Nuke is also one of the rather young projects among them. And I hope I got every one of them.
Right. So, I don't think we're going to do a compare and contrast with each one of those, but maybe you could say like the one or two or three things that that Nuke had, like that are stronger with Nuke, or maybe only exist with Nuke.
One thing where it's quite different, and I think we can see that in the demo then, is that it uses the console application. So there are a couple which actually also use the console application. But one nice addition, I think, is that it uses symbols by default for your targets. So if you think about MS Build, for instance, I will take this as an example. Then if you, let's say, want to rename a target, then you usually end up with search and replace, because they're all strings, basically. We don't have a strong coupling between those. They're not actual symbols where we could use refactoring tools with.
Right.
This is something that's very different in Nuke.
Okay, right, yeah. MS Build is what they call stringly typed.
Yeah, right.
Okay, let's take a. It sounds like you do have some. You have another slide or a demo?
Yeah, I actually have a couple of other slides. So
okay, let's take a look.
Let me see. For those who are not exactly familiar with what build automation is, this is a typical build graph. So we would do something like clean, compile, publish, etc. And the arrows are kind of in the different direction, but that is because of the tool that I use to generate this graph. I want to also briefly talk about the elephant that is in the room, and that is, what about CI systems? Why would I even use a build system that, or a build automation system that works locally, right? And the answer here, it wasn't exactly hard to find good examples for that, because with CI systems, you often end up that you're in a constant feedback cycle. So you push, you wait for something to happen so that it resolves, but in the end, it takes a couple of tries. Also, this is something that I probably shouldn't miss, particularly with CI systems that use YAML for configuration. This is something like everyone probably knows. So you run in those issues where you forget indentation, etc. Another elephant in the room is, what about .NET CLI? And this is where I took this picture from Roslyn, from the repository. And what you see, and I know Roslyn is probably one of the very complex repositories, but what I see is that even smaller repositories eventually turn into something where you have build automation scattered across different files. Like you have it copied for PowerShell and Bash, let's say. You have implementation in props and targets files and so on. And speaking about the elephant, of course, it also depends. So not always, I would say, you should use Nuke. But again, from my experience, it's a no-brainer to start with, if you can say that like that. And eventually, it helps you growing your repository. Yeah, and that's where we can move onto the demo. Let's see here. So what I've prepared here is I have a solution with just one, so to say, production source code project, which is the console app 2, but that doesn't matter so much. What matters is I have already set up the solution with Nuke, and that is by executing the global tool. So there's a global tool which is called Nuke. And after answering a couple of questions, we end up with a project being added to the solution. And this is, if we look into that, we can see it's a simple console application, target framework, latest, basically. And the class itself is really just a static void main method that delegates to some method that will take care of executing the build. And here's exactly what I mentioned. We have the restore target and the compile target, and both are actual symbols. So in this case, they are properties. And I also can define dependencies between those. So for instance, compile depends on restore.
Right.
And the big benefit of having this setup with a console application, I think it's quite important also looking back at what I said about CI systems, is we can actually debug this in a quite easy manner. So for instance, I'm using Writer here, so I can, maybe that was a bit fast. So let's abort this for a moment. So I can hit Alt-Enter, then restore, and can either choose to execute or to actually debug. So this comes from an extension, but I could also do without extensions, of course. So executing console applications is something that every IDE can do. But there are a couple of extensions for each of the IDEs, like also Visual Studio and VS Code, which help actually doing this step of executing targets. Then you see I just hit here on the next breakpoint, and I could then inspect what actually happened. Okay, so but for now I would just stop that, and I would like to implement a couple of concerns here. I mean, like particularly the restore and compile step.
Yeah, I was going to ask about those. Like, where's the implementation for those?
The implementation comes right now. So first, let's start with, and that's something I didn't want to show. Let's start with solution. And solution in this case, one thing about build automation, one very strong concern is also how do I get input values to my build? And this is where Nuke also shines. So this particular one, solution, is actually loaded from parameters JSON. So inside here, I have defined my solution. and that is basically console app 2. Okay, that will get loaded automatically because we have the attribute here. So then we could continue and type .NET Restore, let's say, and I could provide just the solution. That would be enough. Sorry, it was like this. That would be enough, actually, because this way it's just like using strings to execute .NET. But what's even better, and I will get there in a moment, is to use a Fluent API. And in this case, I use a Lambda to further define how my .NET Restore should look like. And that is, in this case, for instance, to call set project, and I pass the solution file. This might seem a bit too much, because basically it's just .NET Restore, right? But where it really shines, if we add, for instance, another parameter, and this is really just an example where we use the ignore failed sources, for instance, which allows us to skip failed sources if they are not available. And in that case, I could just say set ignore failed sources and pass this parameter here. And this parameter I can then pass from the command line, and it will be modifying the .NET Restore call, basically, in that case. For compile, it actually looks quite similar, and I will leave the execution for the end, actually. For compile, it looks quite similar.
Sure. So I have a simple question, which is, this all makes sense to me. I generally see what's going on. The question is when this code compiles, does that reliably enable your build to work? Like, obviously your source might not be correct. I totally get that. But assuming your source is good, does this always result in functional builds, or do you sometimes have a case where this compiles, but for some reason MS Build doesn't work?
Usually it depends. So definitely you would need to make sure to have a couple of, the build will definitely work. That is something that is quite a key concern to build automation in general.
Yeah.
And that is why with the installation, I actually skipped that, but I have a total of 3 bootstrapping scripts, which will make sure that the .NET SDK is installed. And if it's not installed, it will check that it also uses the correct version. And if it's not installed, it will be installed for you in a temporary directory to make it available. So
maybe now that I think about it a tiny bit more, I can ask my question more specifically. So if I was typing .NET CLI or MS Build commands from the command line, there's at least 2 categories of errors I might have. One is that I typed the parameters incorrectly, like they're misspelled. And the other one is I have the parameters spelled correctly, but they're on like the wrong verb. Right? You pass something to restore that's like only legal for build or something like that. So I'm guessing this solution would never have either of those particular error cases.
That wouldn't happen here. So if I understood correctly, at least. So .NET Restore, these interfaces to work with CLI tools, those are actually generated from a very large set of metadata that we gathered, and it's really there are like a couple of dozens tools, including Docker, including .NET, NUnit, any meaningful CLI that you can think of that .NET developers need. And those will generate those extension methods here. So these are all extension methods, and you can actually also see that in the documentation. So this is actually the original documentation from Microsoft website. And down here you can also see which parameters you can define for this .NET Restore call. This is exactly why I like this Fluent API so much, because it makes you visit documentation websites much less, because you have it just at your hand, at your fingertips with auto completion, basically.
Right. So can you show us a build?
Yeah, sure. Let's switch over to compile. And for compilers in particular, I would actually like to use .NET Publish, which does a bit more, but I will also explain why. So for the .NET Publish, it looks very similar. And again, we can pass the project, in this case, also the solution. And I also have prepared here, because it's a bit longer, another parameter, which is called configuration. And this is, you can think of it more or less of a class-based enumeration. So it has debug and release. And that we can actually use because it's also marked as parameter. So we can also pass that from the command line later. And you can also see if local, then it's debug. And if it's a server build, basically, then it will be release. So let's pass that, and we can pass configuration. And now let's say this console app, and I will do a quick modification here, is available in with multiple target frameworks. And now I would like to publish my console app for all those different frameworks, right? What I can do, and I will start a bit earlier here, is to generate some publish configurations, let's call them. Inside here, and this is something very exciting because just today I released a new version from project and let's say I have a couple of projects that must be published for different target frameworks. And I have an enumeration of them, and now we have this solution parameter that we introduced earlier. And you've seen I had generate projects set to true here. And I hope when everything works, then we should actually see that this solution entity here reflects what we have in our solution file, like actually. And then I can pass console app2 here. And what I'm doing basically a permutation here. And the next thing I do is framework. And from here, I just do project. So for each and every project, we get the target frameworks, which can be multiple. And from those, we just grab the project and framework. Like that. And now, of course, we want to combine that because currently we would have two .NET Publish calls, right? That is something that you can also easily do. By the way, you can't easily do that with if you would use a simple process .start or something, because you have to do quite a lot of combining and string manipulation, etc. This is again where this Fluent API shines. I will just combine that with the published configurations. And I admit this part looks a bit funny because I have to do another lambda. But it's actually quite easy because the first is again similar to what we had earlier. So this will actually also hide the outer lambda parameter. And the second is what we passed here. So one of the published configurations. And I think I missed S here. Okay, and now we can do set project, and we would use the v parameter, pass the project, and also set framework and pass the framework. So that would do the publishing, basically.
Makes sense. Is it possible for us to, run this?
Okay, let's see. So there's one thing that I also would like to use source generators for, and that is, I will show a tiny bit of internals here. Nuke also, the global tool comes with shell completion. But currently it relies on the fact that after you change your build, you execute Nuke at least once, which is basically to generate this build schema file, which is then used for completion.
Oh, I see.
So, this is a very good candidate for source generators too. But as soon as I do this, then I can go ahead here, type Nuke, and type C, for instance, just C for compile, and hit tab. It will complete for me. I can further go and hit configuration. So in this case, there's also a continue parameter. So let's use configuration. I mentioned that this is like a class-like enumeration. So I can use R to complete to release. And of course, we also had this ignore failed sources. So this is a very fast way of actually invoking your build with shell completion, and also to avoid typos, like you mentioned earlier. So let's do this. And again, like I mentioned before, during the initial call, it will check if the dotnet, if the required SDK is present. And right after that, let's increase that a bit.
Okay, so while this is happening, how about you also tell us where people can get Nuke to get started?
Sure. So let me give me just a second. So we have a website, of course. Let me get here. Pull it over. So this is the website. Also link one of my recent talks that I did, and everything on the documentation should give you a good idea on where to start. So for instance, including setup, of course. That's what we basically skipped for today.
Sure.
How builds are run, how they are authored. Often I have this little fundamentals subcategory that you can read first. And a lot of other stuff, like one of my favorite topics is actually the build sharing stuff, because that also uses one of the recent C# features, which is interface default implementations, which is such a cool feature to use for build sharing, and a lot of other things, of course.
Okay, well, how about we check on that build to see if it's completed?
Yeah, sure. So let's go back.
And then we should wrap up.
Looks good. So everything worked. And again, what I want to stress here is usually this was a working example now, right? But often in build automation, you end up having issues which sometimes only reflect on CI. And it's really of great help if you can just step into your targets and see what actual values are being passed. One thing I fortunately couldn't show today is one of my favorites people really love about Nuke is Nuke also allows you to generate all those different configuration files, like for GitHub Actions, other pipelines, TeamCD, etc.
Nice.
And it even, and that's also one distinctive thing, it even lets you do automatic parallelization. So for instance, if you have like a 10 test projects, for instance, you can quite easily let them run in parallel.
Awesome. Well, I think this is a great deep dive into Nuke. So thanks for being on the show and showing us your project. And so it's nuke.build is where people can go to check it.
Nuke.build, yeah. I think the top level domain was not exactly meant for things like that.
That's okay. Okay. Well, this has been another episode of On.net where we talked about build automation with Nuke, and thanks for being on the show, Matthias.
Thanks as well. See you.